what we had seen last time was a very basic introduction to Python. And we had also started off with discussing what are the different flavors of Python which are currently available in the market. We had discussed two flavors, if you remember. One was Cython, and other was, it was not Cython, it was CPython. Now, make a note, it was not Cython, it was CPython. Now, let me quickly just revise from the flavors of Python. And then we'll cover up all the flavors quickly before we go ahead to the first introduction. And there is something more that I'll answer, because there are a lot of questions that were asked last time regarding how it actually works, what exactly Python is. So I'll try and answer that question as well. Okay, so let's begin with our discussion from where we left last time. So we are talking about how Python works, and then we started off with alternate various flavors of Python which is there. So here we were. So we are talking about alternate implementation. The first one that we looked at was CPython. Now note, don't call it as Cython, because there is something else called as Cython which is there. There is something else called as Cython which is there. This is CPython. So don't forget to call it as CPython. Now, when we say it's a CPython, that means the entire Python is being implemented in C language. That means whatever operation that you're trying to do, those operations, instructions that we write in Python language will be interpreted by the interpreter, and the code for the interpreter has been written in C language. And we say this was the original implementation that was available for Python, only written in C language, no other language. So when Gaudo van Rossum went ahead implementing Python, it was this C language where he went ahead implementing this particular Python. And even today, when we talk about a reference implementation, that means from where people take inspiration and then create their own versions of Python, this is the reference implementation which is available. This is the reference implementation which is available. So all the new features that we talk about are first appearing over here. It may not be the best as far as performance goes, but it is the most standard one as far as the maintenance goes. So whatever new features that we see, there is a foundation who maintains this version of Python for us. So it's a baseline set of tools for working with Python. So minimum set of libraries which are required, which are integral part of Python, are now supplied over here. We are not talking about additional modules that we can import. I said there are more than 2 lakh implementations which are available. We are not talking about those 2 lakh implementations over here. We are only talking about the core libraries which make a part of Python. Only they will be available over here. And what happens over here? It's a bytecode interpreter. Now today, as I go ahead, I'll throw more light on this bytecode interpreter concept as well. But point is, when we talk about Python, how does it really work? We write instructions in Python language, we said, and they do not directly run on the host machine. We said there is something called as PVM. There is a layer called as PVM that comes in between. And that PVM stands for Python virtual machine. So our code actually goes to the Python virtual machine, and the Python virtual machine interprets that particular code and then it executes. Now today I'll throw a bit more light on this particular aspect as well, because the code that we send is never executed. The code that you and me are going to write is never going to get executed. The code that we write is translated into a format that the virtual machine can understand. Okay, so there is a Python virtual machine. It is emulating your original machine. It's a model of your original machine. It behaves like as if it's an actual machine. And the instruction set that your actual machine understands are different, and the instruction set that the Python virtual machine understands, they are different. This Python virtual machine is like a program, and this program is expecting some instructions, and it's definitely not expecting instructions that you and me are going to write in English, in Python language. So those instructions needs to be translated into a format that the PVM can understand, and that instructions which PVM can understand is nothing but bytecode. So here when we say CPython is implemented in C, or the original Python is implemented in C, that means the entire code of this program is written in C language. Now, what is this program that we have been talking about? Let me give you a look. Let me show you what is this program that I have always been talking about. So if we go back over here, if I take you to the command prompt, okay, there is somewhere I have installed Python on my machine. There is somewhere this Python must have been installed on my machine. So let's check the Python where it has been installed. So we are trying to search where is this Python program that we are running, where is it actually stored. So what I'm going to say, where is python.exe. Now it is telling us where is this python.exe. It is present in C: users, Rishikesh Pisai, app data, local, Microsoft, Windows app, python.exe. Now this is the place where this particular program has now been stored. So let us go to this particular location. So if I go to the location And if I say d star dot star, who will remember such a long path? Can you see this python.exe? Okay, so there is python.exe that has now been stored here. Python 3, Python, and so on. It's an exe, it's an executable file which is there. Okay, it's an executable file, it's a program that is there. And this exe program is something that's going to actually work for us. So while we are running this, what will actually run is this executable program which is there. That's the one that's going to run for us. So this is my executable file which is there. Here we go. And these are the executable programs that they are actually going to run. So it's an exe file. Now, when I actually come onto the prompt, when I go onto this prompt, and if I plan to run a Python program, I go to some folder. I like to be over here. You could give any folder, and then you say python. Now, when you say Python, your Python starts. So here our Python 3.8 has actually started. So what was this Python that we actually ran? That was the program. And this is just a normal program which has been written in C language. Now, suppose if I wanted to execute a program directly, suppose last time we had written some program, I think it was a program called as greet. Let's check. Yeah, we had written a small program called as greet.py. Let's see what's there in that program first. Type greet.py. Okay, so it's just going to ask you and do something. Okay, so there is one program called as greet. I want to run this, so I'm going to say python greet.py. Don't worry about how the instructions have been written. Just see what I'm doing. So when I'm saying python greet.py, it's asking me to enter my name, and I enter, suppose, a name as Rajesh, and Rajesh is 13 years old. So it says Rajesh is 13 years old. So this entire program that we are talking about, this program code has been written in C language. It's an executable program. And this is the program script that we are passing to it as a parameter. So this program, which has been supplied to us by the Python Foundation, takes our script as a parameter. So this is our script. So we have this greet.py. So I'll just open up this greet.py for you. Notepad, greet.py. So this is a simple program that we have written. And now this entire script was sent to this particular program, and this program executed this particular code, whatever code that you got to see right now. We could have written some other program as well. I'm going to come back to it and explain you what is actually happening. Pay attention. If there is any confusion, ask me there and there itself. I'm going to write one more small program for you. A very simple program is what I'm going to write. Watch it, the program that I write. I say Notepad. Don't worry about what that program is. I say add.py. There is a small program called as add I'm writing. And what I'm going to do, I'm going to write one function called as add, wherein I take x and y, two variables. Don't worry about the syntax. Just see what's going to happen as I run this particular program. I say add x comma y, and I say there is a variable called as answer. I say answer is equal to x plus y, and you're going to return the answer. It's simple. So somebody who's not from programming background, he can also make a guess what's happening. We are taking two values, we are adding those two values, and we're returning those two values. And so I gave a call to this particular program called as add from anywhere. So I say add, and I pass 3, 4. There are two values that I'm going to pass. So that's the small program that I have. Correct? So whenever I run this program, Python add.py, okay, I executed that program got executed, but we wanted to see the answer. So if you wanted to see the answer, I could have printed this result. So I could have just said print whatever is the answer I want it to be printed. Don't again worry about what is happening. Just see answer is what we have got. Can you see that answer 7? Now, if you are under impression that the program that we wrote is the one that got executed, there is a mistake. So this is the program that we have written. But here, whatever instructions are there, they are in English language. And English is definitely not a language that the machine can understand. Neither your actual machine can understand, neither the virtual machine can understand. These are not instructions that the machine can understand. This is Python. And Python cannot be understood even by Python virtual machine. Neither can it be understood by your or my machine. Linux, Windows, nobody can understand this. This is instruction in Python language. Now, somebody has to translate these instructions into a format that the Python virtual machine understands, because the only kind of instruction that the Python virtual machine understands is bytecode. So somebody is going to translate this code into bytecode. Listen to what I'm saying. Somebody is going to translate these instructions into bytecode. Let me show you the translated code. We have written this particular program called as node.add.py is a program that we have written. Correct? So let me just open up this program once again. This is a small code that we have written, and we are under impression as if this is a program that is running. And when I'm running this program called as Python, and if I say add.py, it looks like as if this add.py, and we got the answer as 7. Can you see that? Answer as 7 is what something that has got printed. Okay, so answer as 7 has something that has got printed now here. Now let me show you what actually got executed. This is the code that we are seeing. This is the code that has been written in Python language. Somebody has to translate this particular code from Python language into a format that the Python virtual machine can understand. Okay, or the interpreter of that particular machine can understand. So there is someone who is doing this particular translation for us. And when is this translation happening? Believe me, it is happening when you are writing this instruction. When I said Python add.py, this Python is a magical program that we have, and that program is doing a lot of stuff, operations for us. This particular program, Python, is doing a lot of operation for us, and then it is reading this particular script that we have written over here. So what I'm going to do now is I'm going to start with Python, and for some reason I want to check that particular code that we have just now seen. What is the code that we had? We had some code that we had written. Add something is what we had written, but we have that script over here. So maybe again I'll type. I say add. I had x comma y, and then I had written add x comma y, and I had variable called as answer is equal to x plus y, and return answer. So don't worry if you're not understanding what this code is. Just have a overall picture what's happening. Say somebody want to add 5 and comma 7, so it says 5 comma 7 is 12. If somebody adds something else, I add 10.4 comma 54.7, we got that answer. And I add something else, I add Anil comma Kapoor, and if I do that, it says Anil Kapoor. So addition is happening. It's not just about numbers, anything can be added. Okay, so what we just now saw was a code that we could read, but that's not the code that the Python can actually understand. Python means the interpreter can actually understand. So what has happened? This code has got converted into bytecode. Let me show you the bytecode of this particular code. Okay, so just see the output. Don't worry about the command that I'm writing. You learn those commands over a period of time, and there is nothing special about these commands. So this is the code that actually got executed. So we have written something else, and what is getting executed is something else. What we have written is this particular code. Let me open up that particular file for you. What we have written is this code, correct? And what is actually getting executed is this code. So when I'm saying bytecode, 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 these are the bytecodes. So the program that we have written has been converted into bytecode, and these bytecodes will go to the interpreter. So let us draw a simple picture to understand how is it actually working. Say, let me know if this screen is visible to you all. Is this black screen visible?
Yes, sir.
Okay. So what is happening over here now, we have written this script. That's my script, that program that we are talking about. So this was our program called as, or a script called as, it was add.py, inside which all the instructions were written, correct? And we got the output as somewhere. When we pass numbers, we got the output. So somewhere we got the output also onto our console. So here we got the output as well. I say 5,2, if I pass, we got over here output as 7 as well. We got the output as 7 as well on the console. So this is my output screen, my console. Output screen, we got the output as well. What is happening in between is something which is very important, and that is something that we need to understand. What's happening in between while I'm writing this kind of instructions? What is happening? So we wrote this particular program. This program had instructions in Python language. This program had instructions in Python language. These instructions have now been transferred to your Python program toolkit. But actually within that particular Python program, there is a compiler also which is there. Now I'm going into a bit more details to help you understand what's happening. So there is a compiler that is there. So there is a compiler that is there in between. And what is that compiler doing? That compiler's duty is to translate that particular code. So there is a small compiler that is there. And this compiler doesn't do much. It's the simplest of the compiler that you can ever come across. So there is a compiler that is there. Rather, every language has a compiler. But we still say Python is an interpreted language. We do not say Python is a compiled language. Why? Because this compiler doesn't do much. What it has done, the code that we have written, the code that you just now saw, add program that we saw, that is only translated in that format that we saw. That means first we wrote this particular program. So we wrote this program. This program was actually later translated. It was translated in this particular fashion. And this is what your compiler did. So we wrote the code in English-like language, and that was translated to bytecode. So output of this was nothing but the bytecode. So when we wrote those English-like commands over here, they were translated by this particular compiler into something called as bytecode. So what we got over here was a bytecode. What we got over here was a bytecode. So here what we got is all those bytecodes, load and other commands that you saw. So those were nothing but bytecodes is what we got. So what we got is a bytecode. These bytecodes are now forwarded to the interpreter. And this interpreter is actually going to translate. So this bytecode will be sent to the interpreter. These bytecodes will be now sent to the interpreter, and this interpreter will translate this particular code, bytecodes, and execute those code to give you the output. So this code goes to the interpreter now. So we had bytecodes will go to the interpreter, and this interpreter is going to do the major work for you. Now those who are from programming background, I'm going to show you something very interesting. Interpreter. And this interpreter that the code goes to, this interpreter executes that bytecodes to generate the output. So this is the actual sequence. We write the program in English-like language that goes to the compiler, and from here till here, watch it, from here till here, this entire thing is nothing but by python.exe, the program that I'm executing. So when we say we have the Python, when I write in Python add, that one program Python is having my compiler that is generating the bytecode. Bytecode is given to the interpreter. Everything was present in that one program that was python.exe, python.exe. We have written this particular code, correct? This entire code was translated by the compiler to create the bytecode, entire code. Okay. But then we have been saying Python interprets one line by line. Yes, I'm still standing by the statement. Python doesn't read the entire code. It reads one by one line after another. This interpreter will not take the entire bytecode. It will take one line from the bytecode, interpret it and execute. One line from the bytecode, interpret and execute. So interpreter is going to interpret one line at a time from these bytecodes.
Sir, if you don't mind, can you just explain it once again?
Okay. Say we are starting with the program, and what we have written over here, let me just take, instead of drawing the picture, okay, I'll explain with some other way. This is the code that we have written.
Correct.
Okay. Now this code, when we are running, what we are actually doing is we are doing something like this. Sorry. And we are under impression the program has got executed. We have said Python add, okay, dot py. Oh, py. And we got the answer as 7. Is that okay? Till here it's okay?
Correct.
So I'm explaining you what is this Python all about. So I told you Python is nothing but a program. Okay. And that's the entire Python for us. So what is this? This program has been written in C language. So what we are currently using is C Python, because this code for Python has been written in C language, and I can show you that code. It has been written in C language. So when I'm running, I'm actually running python.exe. What I'm running is python.exe file is what I'm running. Can you see that? I said python.exe add.py, just an executable file is what I'm running. And to that executable file, I'm supplying this particular program. I'm saying run this particular program for me. So what is this python.exe doing? So there are some things which are present inside this python.exe. The first thing that is present inside this python.exe is something more than what I discussed last time. So every session will go a bit ahead. Inside this python.exe, there is a small compiler. And this compiler does not do much. It only translates these instructions that we have in Python language, into a format. And what's that format? I want to show you that. Okay. Yeah. So when I go into Python, So that's our code. That's what we have written. And the compiler is going to translate this code into this particular fashion, into bytecode. So this operation has been done by the compiler. So you can see it says load the first value, it loads the second value, then do the binary addition and store the result into answer, and then get the value from the answer and return that particular answer. It's a simple code that we can understand. I can actually help you to build a Python engine as well. So that's actually simple. So these are the bytecodes, correct? Now, till here it is okay, Dheeraj?
Yes, yes.
Okay, so we wrote a code in Python language and we send it to something called as Python as a program. Within the Python program, the first component that is there is a compiler. What is this compiler doing? This compiler has now translated this code into this format.
Correct. Bytes.
Okay, and this code now goes to an interpreter.
Okay.
This code now goes to the interpreter, and what does interpreter do? It reads one line. I'm going to show you that. It will read this one line, and if we are saying load fast, there is a concept of stack over here. So it will load the first element onto the stack at the 0th position. Then it's going to load the second element that is there from the stack. On the stack it will load. So it's just going to load some elements. So I'm saying do this operation. So interpreter, when we say interpreter, interprets one line at a time. So our interpreter will perform this operation first, then it will perform this operation, then it will perform this operation, then it will perform this operation, then it will perform this operation. So interpreter is going to interpret one line at a time. Now, what comes to your mind? Even people from non-computing background should tell me. If you hear a term called as interpreter, what comes to your mind? Especially now, those who from computing background, don't tell me. Those who are from non-computing background, tell me what comes to your mind when you hear the term interpreter. Mallar, come on, tell me. Prithviraj, tell me.
Something which shows, which displays.
No. Anybody else? Interpreter.
Translates.
Translates. Okay. Okay. Interprets. Understands. Okay. Interpreter. Somebody who will interpret. To translate, somebody has to understand and then he has to perform some operation. Na? It's like translation. It's like interpreting, understanding what you're trying to say. Okay. So there is this interpreter which is there. And this code of interpreter has been written in C language because it is C Python. So what it will do is it will read this instruction. What is the instruction that you are given?
X and Y.
No, the first instruction that has been given is
Load.
load fast.
Yeah.
Load fast. So it has to carry out operation according to the instruction. So the interpreter doesn't apply its brain. The interpreter just reads these instructions and carry out operation according to the instruction. It's a dumb thing. It will just read this instruction and carry out operation according to the instruction. Then it will read the next instruction, carry out operation according to this instruction. It will read the next instruction, carry out operation according to this instruction. So interpreter is just interpreting this code one line at a time. Is that okay, Dheeraj?
Yes.
Okay. Now this interpreter code is a C language program. And there are hundreds of bytecodes which are actually there. There are hundreds of bytecodes which are actually there. Bytecodes. There are hundreds of bytecodes which are actually there. Can you see this list, everybody? Is that visible?
Yes.
Yes.
Okay. Right now we saw one. Which one did we see? Binary add?
Binary add.
Correct. So there are so many bytecodes which are there. Can you see this? And every bytecode has a meaning.
So the function that we use, dis.dis, does it shows that?
Don't worry about that. Just forget about it. Let's
Okay.
not go into this. I'm going to explain that module in detail with you.
Okay.
But just focus on these bytecodes. Every bytecode has a meaning.
Correct.
Yes.
Correct.
The one of the bytecode that we saw was load fast. Load underscore fast. Correct. So it says pushes the reference variable, do something onto the stack, do such operation. Is there a work? Yes or no? Every bytecode has a meaning. This is operation that has to do. So if you come across this bytecode, interpreter will perform this operation. Now tell me, if I have to perform any operation, what do I need? Anybody can answer. If I have to perform any operation, what do I need?
Bytecode.
No. Now, pardon? How do you perform any operation?
An operator and operands.
That means there are some instructions. Yes or no?
Yeah.
there has to be some instructions which will tell us how is that work to be done. If I say brush the teeth, that's an operation, but for that I need to take a brush, put the paste onto it, and then brush the teeth, and then whatever rest of the operations will be there. So there are sequence of operations that need to be done to get that work done. So load fast was one command, and to get that thing, this is the operation that we had to do. And to perform this operation, there are a number of steps that we'll have to follow. And this is what interpreter actually does. The entire code for interpreter has been written in C fashion. Can you see this switch case? This is my opcode, that's byte code. It says, if you come across this byte code, do this operation. If you come across this byte code, do this operation. And what if I come across load fast? Let's search for load fast. So I'll say find load fast. Okay. So it says, if you come across byte code called as NOP, do this operation. If you come across byte code called as load fast, do this operation. So it is just regular C code. Can you see the extension eval.c? And as many number of byte codes that you have, that many number of cases will be there. So this is an interpreter which is running. What is interpreter doing? It's reading one line. So it will read this line first. You read this line. क्या कहा गया है यहाँ? Load fast. So it will go here and it will search target load fast, load fast. So it will carry out this operation. Is that okay? So it reads the instruction, carries out this operation. And for those who are from programming background, something a shocker for you. So there is a switch case, how simple it is for us to implement a bytecode if you're a C programmer. There is a switch case, and for every bytecode, there is a case. And likewise, how many cases do we have? Let's check it out. Our switch case starts over here. It may be the largest switch case that you may have ever seen in your life, or you will ever see in your life. It starts at line number 1323 and goes on to look at that. It's just switch case. For every bytecode, there is an operation. Which are bytecode? If you get this bytecode, do this operation, it's saying. And it is continuing. कहाँ तक continue कर रहा है? Default. यहाँ तक. यहाँ तक. End of switch. How many lines? 3701 minus 1323. How many lines? More than around 1500 lines? Yes or no? Yeah, more than that. Around 2000 lines.
2378.
Pardon?
2378.
That means more than 2000 lines. That means more than 2000 lines of switch case construct is what we are having. And I have seen some compilers not be in a position to handle such a big switch case. Huh? Okay, so it says if this is the bytecode, do this operation. If this is the bytecode, do this operation. So that is what the interpreter does. Interpreter will read this instruction, and then there is one C program that will tell if you come across this instruction, this is the work that you have to do. If you come across this instruction, this is the work that you have to do. It will just interpret it one line at a time. If somebody tells you why Python works slower, look at that code. It's a clumsy code, very big if else switch construct, and there is no optimization that has been applied over here. So that's one big reason why Python program can possibly run slow, because it is just, there is an infinite loop actually over there. And that infinite loop, what it does, from this program, read one instruction, carry out the operation, then read the next instruction, carry out the operation, read the next instruction, carry out that operation. And so it keeps on doing till all instructions in the program have not been executed. Have you understood this? Anybody has a query? Any questions, even non-computing background, if you have some difficulty, please ask. So I have got into a bit more detail because there are a lot of questions last time. So I thought, let me open up the thing and let you know. So we write the Python code. As a Python programmer, you need not know this. That's okay. But just to help you understand what's happening, because people say Python is an interpreter language, and then they are under opinion that there is no compiler involved. There is a compiler involved, but this compiler does hardly any work. It has only translated our English Python instructions into bytecodes. It has done nothing more than that. It's not like a C compiler or a C++ compiler or Java compiler doing something fancy stuff. Nothing of that sort. It's just taking the C Python code, translating into bytecode, and the interpreter is reading one bytecode from here and interpreting it. Interpreting means carrying out that operation. So it is the logic has been implemented in that interpreter. It's a big program called as ceval.c. It's a pretty big program. If I just scroll to the bottom of this program, it's a pretty big program that is there. Huge program. Let us go to the bottom. It's almost a 6,000 lines program, 5,620. Someday we can build someday अगर workshop लेंगे तो I'll be more than happy to do that. We can build a mini Python, say 4 command समझने वाला Python, because 4 समझे क्या और 400 समझे क्या, logic remains the same. So someday we can do a small exercise. I have implemented it for 3 commands. तो 3-4 command का एक छोटा सा Python create कर सकते हैं. And it's just like somebody who knows C language will be in a position to play with it, or any programming language. You can play with it. It's stack-based Python execution. So you know थोड़ा data structure क्या है, stack पे evaluation क्या है, they will understand what operation, how it can be done. Accordingly, likewise, we had this alternate implemented Jython. Now, can anybody quickly give your opinion about what they may have done in Jython now? Actually, what happens is the code, the bytecodes that we saw, it will not be the Python bytecodes now. Okay, it will now be converted. So there is one more step. So when you write this Python code now, that add program that we have written, we got that load fast and so those commands what we got, correct? Save fast, load fast. Now you'll not get those commands called as save fast and load fast. You will get those commands which are Python bytecodes, which are Java bytecodes, which JVM can understand, Java virtual machine can understand. So it's going to run on Java. So Java has its own machine called as JVM, Java virtual machine. So the code will now be translated. The compiler will now translate the code into a format which not the PVM understands, but what JVM understands. So it is now going to run on Java virtual machine. Is that okay? And because of this, if it's going to run on Java virtual machine, you are writing a code in Python language. Somebody asked me, code kis language mein likhoge? You are writing a code in Python language, but your Python language code is going to get translated into Java bytecodes. So here you have an opportunity to call Java functions. That means whatever ready-made features are there in Java, you can call them in Python. And so that you can, and it's after all going to work on Java virtual machine. So if it's going to work on Java virtual machine, I can make the full utilization of power of Java as well. Because your Python is converted into Java bytecode. So you have an opportunity to call Java class libraries, and whatever features that you may have learned in Java, all those can be used in Python as well. So you have Python codes plus Java code. So it's much more powerful than regular Python that we have. It can do more than what your Python can do. So here too, there is a compiler. You write Java Python code that goes to the compiler. Compiler does not translate this particular code into Python bytecode. It will translate this code into Java bytecode. And these Java bytecodes will not be interpreted by Python interpreter. They will be interpreted by the Java interpreter now. This is the beauty. This is the most important thing that I wanted you to understand. If you all understood this, I don't really have to take up the other formal implementation. That means we are now independent of the language. We only require bytecodes. So your Python can be translated into any other language and we can run it. So, but you as a Python programmer, do you have to bother about learning Java or C or some other language now? You can write Python code and your Python code can actually run on any language platform. Are you getting? Okay, likewise, what we also have is a IronPython. Now this IronPython, like what we had C Python where the entire code was written in C language. So here IronPython, everything has been written in C hash. That's the Microsoft technology. And it will not run on the Python virtual machine or Java virtual machine. It will run on .NET virtual machine because .NET has its own architecture. So on the .NET framework, this entire program is going to run. So you're going to write the Python command. This Python command will be translated. Okay, the Python commands that we are writing will not be translated into Python bytecodes now. Now these commands that we have written in Python will be translated into a format which the .NET framework can understand. And the .NET framework understands something called as Common Language Interface, okay, CLR. So it will convert the Python programs into something similar to CLR, which will run on .NET platform. So you're writing a code in Python and that's running on .NET platform as well. So you have an opportunity over here. You can write a regular Python code, run it not just on Java, JVM, you can run it on .NET as well. So if you want to run your Python program on .NET, you need to have IronPython. Now, while we are doing so, that means we can now over here utilize the functionality of .NET platform. So a Python programmer has a power to use the feature of any technology that he like to have. He wants to use Java features, he can use Jython. He wants to use .NET feature, he can use IronPython. And now he can integrate the .NET commands in Python program, and he can make the best use of Python as well for that purpose. Yes, please. So this was created by the same person who created Jython. The same fellow also created IronPython. So there are multiple implementations for .NET on Python which are available. IronPython is something which I just took it for sake of demonstration. But then there are multiple implementations which are available. There is Python for .NET also, which is available. IronPython is more standard, so I mentioned about IronPython. But there are alternate implementation also available for you to run Python programs on .NET. So in .NET, what happens is you have multiple languages that you may be working on, but at the end of the day, in whichever language syntax you may have written, it always gets translated into something called as common language there is some common instruction set which is there. So you may write a code in VB.NET, you may write a code in CH.NET. What will happen is those codes will not get executed. Like here in Python, we had that intermediate code like bytecode. Here also we'll have some intermediate code. That's common language runtime, some intermediate code will be available. So the .NET programming languages, whichever .NET language you may use, CH or VB.NET, that will always get converted to some intermediate language. Like over there we had bytecodes, here also we have intermediate language, and that intermediate language will be executed by your .NET platform or .NET virtual machine. So now this IronPython will give you an opportunity to convert your Python program into a format which your .NET can understand. Likewise, we also have WinPython. Now, suppose you are a programmer who do not plan to work on Linux machine. You are working only on Windows machine. So we have WinPython over here. What's the good thing about this Windows Python? I had asked you to download Python and install Python. This Python need not be installed. This is just one zip file which you need to unzip. I have uploaded on the site. You can download it. You have to just unzip and you will get a folder. And inside this folder, you will have Python along with the IDE. No installation necessary. You can just double click and your IDE can start. If you want to, you can just double click and your Python can start. And number of data science packages which are required, like NumPy, Pandas, SciPy, Matplotlib, all of them have been included inside it. So no installation required. A bundle which is available, and you just unzip that bundle like you unzip any other file, and it's there in the folder. And you want to uninstall, just delete that folder. Work is done. So there is a very lightweight kind of WinPython which is available. So no installation steps required, nothing. You can just unzip and start working it. But unfortunately, it works only on Windows. It does not work on any other operating system. And it also has this C++ compiler, so that translation, everything will happen just like it happens with your regular C Python. It will work in that fashion. We also have Python, which has been implemented in Python, and that's PyPy. So right now, earlier we talked about Python implemented in C language, then we talked about Python and Jython, then IronPython. Now we talked about Windows Python, that is again in C language. We also have Python implemented in Python. So that's PyPy. So this Python has been written in Python. Now anybody can tell me, when I'm saying this Python has been written in Python, what is written in Python? That executable which is there, the compiler and interpreter, both have been written in Python. That's how it is. It supports several advanced features not found in implementation like stackless support and just-in-time compiler. So this is far more superior in terms of performance as compared to any other previous implementation that we have. And when I say superior, the C Python, if you compare, this will give you on average almost 8, that is 7.7 to 50 times better performance than C Python. Look at this, what I'm saying. It is still nowhere near your C language or C++ language, but because it is just-in-time compiler which is available, that feature that is there, its performance will improve. How much? What performance we had with C Python? It can improve 7 to 50 times. 7 to 50 times. That's substantial improvement in performance we can have by using PyPy. Okay, so if you compare with the standard implementation which is available, this can give you better performance. And the implementation is also totally different. So we have Python, which has been implemented in Python as well, and that's PyPy. We also have something called as MicroPython. Now, this is something that you should be aware of. The image that you get to see is a real image. That's of a Pi board. Now, sometimes you have a bare metal. That means you do not have a computer. And when you do not have a computer and still want to run a Python program, listen, those who are not from computing background, listen to it very carefully. Till now, we have been talking about programs which are running on the computer. So we have a processor, we have the hard disk, we have the operating system, and then we are running our program onto that particular machine. Sometimes it so happens we are planning to run a program on bare metal. That means in a car or in some device, and there is no computer. So if you want to run a Python to perform some basic operations or some selected number of operations, and that too that Python should run on a device which is not a computer. So if you want to run a Python on a device which is not a computer, what you have is MicroPython. To run this, and it's a minimal subset of Python language. That means it is not like a general purpose language. You cannot create graphical user interface, buttons and everything. No, that cannot be created. But some logic is to be implemented to carry out some kind of operation. You want to control some device through your program, and that program is not going to run on a computer, there is no computer and you still want to run a Python program, you can install this PyBoard. And this is not the only option, but this is one of the standard one which is there, people accept it, so I have mentioned about it. So other than MicroPython, there are other implementations also which are available. So there is this chip that you'll get to see, and in this, only thing that can run is a Python program that can run. So it will have low level Python operating system on which only Python programs will run. So if you have an need to run Python programs on a device which is not a computer, you have MicroPython which is available for you. And this doesn't cost much. This PyBoard doesn't cost much. It has all the IOs that we require, input, output things that we require, so that we can control the devices. So those basic operations are all provided. So any electronic project that you like to implement, where you want to control some logic has to be given, you can very well write that code in Python and run it through this MicroPython. And it's a minimal implementation of Python which is available. So we have MicroPython as well. We also have something called as Portable Python. Now this particular Python, again, I have uploaded this on the site. Do download this Portable Python, run it and see. It is a CPython runtime in self-contained package. Remember last time we told, somebody was asking me, sir, वो Python install नहीं रहेगा तो क्या करोगे? अरे नहीं रहेगा तो ये Python portable हम लोग supply करेंगे. Okay, so there is no need for you to install Python. This can live in some directory or some pen drive. You can keep your Python in a pen drive. You can keep your Python in a hard disk. You can keep it anywhere, any directory you could keep, and you can directly run. So if you want to launch, you want to create a script through which you want to launch a program on the client machine. So you'll write a small script check on the client machine if there is a Python installed. If there is no Python installed, then our program will run by using this Portable Python. And it includes, very good for a developer, it includes the IDE as well, Spider, the one that I'm going to use. It will include the IDE as well. So you can type the program also using this Portable Python. You can run your program also using this Portable Python, and no installation necessary. Everything that the CPython actually wants has been included inside it, and we can just keep it into a folder and just run this Portable Python. And it can be used for data science, Plotly, SciPy, everything is there. Most of the things are there over here. So it runs without needing to install on Windows. So you do not install it on Windows, just unzip it and we can run it. So we can write one script which will check if the user machine doesn't have Python installed. So we will bundle along with our program this Portable Python. So giving the path of the Portable Python, it can run the program as well. So if you really want to run a program on a machine where there is no Python, so when you create your bundle, distribute it and give it to the client, you can include Portable Python into it. And we can write a small script to check user ke machine pe ye program already installed hai ya nahi hai. We can very well do that. So we have Portable Python as well. I hope you are making notes. Huh? Now, there is another language which is actually making a lot of news in the market right now as a replacement, possible replacement for C language, a language called as Rust programming. C language, there is always the problem of pointers which is there, memory leaks, and C is said to be quite a difficult language. And if you want to have a language where garbage collection, everything can happen, a simpler version of C language where you as a programmer do not have to worry much about memory management, comes a language called as Rust. So Rust is now, we say, the new generation's C language. That's what they have been talking about. I do not know how popular it will become, but there is a lot of news about this language called as Rust. So if you are a C programmer, but you are not very comfortable with C language, and you do not want to take the responsibility of memory management, you can always think about a language called as Rust. It's a kind of C language where memory management has been taken care of for you. Automatic memory management will happen for you. So we have Python implemented in Rust as well. So here it will provide you that memory safety and also improvement in speed is what we can get. But the only problem is today, the implementation of Rust Python which is available is not full-fledged. All the features of Python have not yet been implemented. And if you want to contribute, they will welcome you for contribution. So for that, only two prerequisites. You need to learn Rust language and you have to join this particular open source project and add a few more features to this Rust. There is a lot of work which is happening right now. So you can contribute to this open source project by writing code, because this code is not written by some organization. There are people who have just come together. They're contributing. It's open source hai, foundation hai. Koi unko pay nahi kar raha hai. So if you want to contribute, you can contribute to this project as well. Now, I said don't say Python, because CPython and Python are two different things. So this Python is nothing but an optimizing static compiler which is available. This gives you the combined power of Python as well as C language. Okay. Here, this write Python code that calls back and forth from C and C++ native code at any time. Now here, from a C code, I would like to call Python code. From a Python code, I'd like to call a C code. Okay. So Cython, what has now been supplied to us, is a wrapper for C libraries, embedding C Python into existing application. So you have C Python, which has been, we can add into, that is your Python can be added into C. So we can make power of C, power of Python can be utilized in C as well. So we have this compiler which is available, which will allow you to implement it. So it is more of a compiler that will allow you to combine Python and C language together. So Cython and C Python are two different things. Keep that thing in mind. So this Cython is more like a compiler which will allow you to combine C and Python. And so this is different. So what does it do? It is an idle language for wrapping external C libraries, embedding C Python into existing application. So we can have the Python, C Python is Python, can be embedded into a C application. So we can add Python to C by using this C Python. And they have an opportunity to do both. C code can call Python code can call C code. So C Python is different and CY Python is something which is different. Thank you all. So we stop here today and we continue with a further discussion. Next session is again going to be a deep dive into some advanced concepts.